Hi, my name is Nick Borson, and in this video I'm going to talk about how to think like a programmer. So what do I mean by that? I've seen some comments sometimes from people who are just starting out learning how to program, and they've gone through some tutorials and they've learned some of the mechanics of programming, like, in a particular language, what a variable is, what a loop is, what a function is, things like that. But then if they have an idea and they want to write a program to implement that idea, or if they're assigned an idea, they kind of are, confronted with a blank page and they don't really know where to start. They don't know how to go take that idea and go from that to an implementation, to a program that implements that idea. So this video is really about that, and I'm going to implement this. I'm going to write a program in PowerShell, but a lot of what I'm going to talk about is not really specific to PowerShell. It's really just about how to go from a general idea of what you want, of a program to the thought process that allows you to get to an implementation in some language. So this is going to be kind of a live programming demo. I think one of the issues with tutorials, with a lot of tutorials, is that for this kind of thing, is that they give you a false sense of just how clear-cut things are when you're programming, because people already know what they're going to write. They've probably practiced it and written it before, and they're just going to go and they know exactly what they're going to do, and they don't show you any of the wrong turns or dead ends that they might take in the course of actually thinking through how to program something. They already know what they're doing. So in this, I'm gonna actually, I have an idea for the program, but I haven't really thought it through in any kind of detail. I haven't written anything down except what you see on the screen right now, and so you're going to get to see the thought process that goes into taking a very general kind of idea and turning that into something concrete that can be written in code. So some general ideas here is that when you write a program, you start with an idea, of course, and then you iteratively refine that idea. So iterative means like a loop. You're going through this process where you're starting with a very vague idea, and then for each step of the way, you kind of refine it a little bit, and then you refine it a little bit further and a little bit further. You don't try to do it all at once. It's a repeated process where you get closer and closer to something that's concrete enough to be written down in code. As you do this, it's important to avoid getting bogged down in details too soon. When you're starting out, you're really keeping things very vague, very hand-wavy, and keeping your options open, and avoiding spending a lot of time on how exactly you're going to implement something. Because as you refine things, you're going to find, well, actually, I have to do that a bit differently. And so if you get prematurely into defining a lot of details, you're going to have to throw that away because you're going to change your mind about some stuff. So you want to start with the big picture. You kind of develop that a little further, and you find that you have to change some things. You develop that a little further, you find you have to change some things. So you want to keep your options open as you're in this early stage. And it also means that you're having to be comfortable with uncertainty. You really don't know. You have kind of an idea of where you're going, but you don't want to be too concrete about exactly where you're going. You want to be able to change your mind as you think things through. So that's part of the. It's very tempting that as soon as you think of something, you think, okay, how am I going to do that? And then you go into a lot of detail up front. That ends up not being. That ends up kind of locking you into something too soon. Then when we get to actually writing code, you have your design. Your design should be such that you have kind of your overall design, but you have this, the whole program might be fairly complex, but it's made of simpler parts. So you decompose the complex thing into simpler things, and each of those simpler things can be decomposed into simpler things until you get down to things that are simple enough to just be single functions or what have you. And as you write your program, then you can write the little pieces, and each of those little pieces can be something that can be tested. You can have some sample input, sample data or whatever, and run that little piece. So you're not sitting down and writing, spending many hours writing code that you've never run and don't know if it's going to work. So writing testable chunks as you go. Okay, so let's talk about the pardon me. Let's talk about the program that I'm going to write right now. So in my family, we used to have my wife's side of the family. She has quite a few siblings, and we used to have this kind of gift exchange we do at Christmas time, where there were too many people for everybody to give gifts to everybody else, so we would draw names out of a hat, and that's how we would decide, who sends uh, who sends gifts, to which other person, and we literally did it just by picking names out of a hat. Um, so my thought is, this is kind of there's really no reason to automate this. It worked fine to draw things out of a hat, but as a fun little program to write that can be done in a short enough time, I think, for a video, I thought it might be kind of a fun little script. So the idea here is we'll write a program to automate this drawing names out of a hat, and then assigning each person who they're going to give a gift to. So let's refine that a little bit further. So that's the idea. Now, just to look ahead here, one of the challenges if you're starting out programming is what is a good idea? What is a good project to take on? And I think it's very important to pick on something that's not too big, right? That has to be, start with something with simple things, and you can work up in complexity as you go along. So this is a very simple idea. We're only looking at, maybe we can kind of, without getting into details again prematurely, we can at least kind of look ahead and think, well, what is this maybe going to involve? Well, we're going to have a list of names. We're going to kind of randomly assign different names to each other. We're going to produce some kind of output that maybe somebody could put in an email or something to send off. We could even have the program generate an email, but that could easily be a separate program. We could just generate a little text file or something, and then if we wanted to get it more ambitious, we could have another program or a feature of this program that allows us to create an email. But I'm going to keep it simple. Let's just create a text file that has a list of names each person will give to somebody else. So we're looking at something to do with random numbers to randomly assign things. And I happen to know there's a rand class in the .NET, or random class in the .NET framework we can use for that. And we're going to be reading and writing text files, perhaps, or taking, having a list of names. So it's pretty simple. So this seems like it's achievable here. So it's an appropriately sized idea or project. So let's refine the idea a little bit further. And here we're kind of starting with this gift exchange thing. We have kind of a scenario, a user scenario. This is kind of a good way to start thinking about the program. It's just, what is the user trying to do? They have a list of people. They want to assign each person who they're going to give a gift to. So everybody gives one gift and everybody receives one gift. So this gives us an idea. Well, we can refine this a bit further. Let's say we have the input to the program is we have a list of people, list of names. Okay, and the output of the program would be, now when I say list of names, I'm not trying to be too precise yet about exactly what form this will take. Is it going to be a text file, or some other kind of file? What's the format of that file? Let's keep our options open. This is this stage of our thinking. We're just being very general. We need some kind of list of names that we're going to assign. The output will likewise be kind of a pairing of names, I guess we could say. So we have basically from two pairs. So we could imagine that as maybe being like a table or something, you can think of an Excel spreadsheet or something where you have a from column and a to column, and each person is, visualizing this, maybe let's stick with that for now. Now there was one other additional detail that when we drew names out of a hat, which was that we had a rule that that the person wouldn't receive the same name wouldn't give the same person they gave the previous year. Okay, so that adds a little extra complexity to our program, because we need to have the previous pairings as another input. And of course, so we refine this further and we think, okay, what other rules do we have? Well, you can't give to yourself, right? So we can refine. So this is like an additional requirement. don't give to self, or don't pair with self, let's say. Don't repeat. Oops, it's supposed to be repeat. Previous pairing. Okay, so we've gone from being very vague as far as all we're looking at is we're drawing names out of a hat, to being a little more precise, where now we have some idea of what our inputs are. We have our list of names, we have our previous pairings, and we produce a new pairing of names, and we have some specific rules that our output has to meet. We don't have the name is not ever paired with itself, and we don't ever have a name pairing repeated from the previous pairings. And maybe the previous pairings should be optional because we might not have pairings from the year before. The very first time we do this, for example. Okay. So now we can maybe think a bit more about how exactly will you run this program, and what form will these inputs and outputs take. For example, maybe the list of names in the previous pairings could be the same thing, right? The previous pairings is already going to include the names. We only need the previous pairings, and we can infer the list of names from that. So this is where you kind of think through scenarios a bit more of like what's going to happen and what are different things that can arise. And that maybe would rule that out because, for example, maybe the list of names might change from year to year. Somebody marries into the family, or somebody else is born, or somebody dies, or what have you. In which case, the previous pairings really doesn't serve as your list of names. So the list of names really should be separate from the previous pairings, and we can't assume that a name that appears in the previous pairings is always going to be in the list, or that every name in the list is also in the previous pairings. Okay, so that's something to be aware of. Okay, that's good enough for now. Maybe the pairings could be, what format will the list of names take? Well, one option is just a text file with one name per line, right? Another option would be something like a CSV file, which is a sort of a text-based representation of like a spreadsheet, basically a comma-separated has comma-separated fields. That would allow us that input file to have additional data along with the names. For example, maybe you want your list of names to have, the name in the first column, but then maybe an email address or something, or some other columns that have other information. That would be an advantage of having a CSV file. Looking ahead, maybe then we could use that in order to generate an email, right? You could have all those, your list of names would include both names and email addresses, and so you could generate an email with your new pairings that includes all those email addresses as recipients. So that's an interesting idea, but again, let's not lock into that. Maybe we could start with just a text file for now, and we can always change it later if we decide we need that. As far as the pairings of names, how would we produce that output? Again, that might be a good thing for a CSV file. You could imagine, a table with a from column and a to column, and you just have a name in each column. Seems like a CSV file is a natural way to represent that. Okay, so but we're not going to lock into that. That's like one possibility. Okay, so now we have some idea of how our input and our output looks. Probably would have we probably have a script with a couple of parameters. One of which is a file name of a text file that contains our list of names, and another one is a file name of an optional file name of a CSV file, say, or a text file that has our previous pairings. The previous pairings would be in the same format as the output, because you would just point to the output from the previous year. So here, let's go ahead and include that detail. Same format. And then the output the program would produce would be the the new pairings that we generate randomly. Okay, so let's imagine then what does our program actually do? So the structure of the program would be, basically we have to process parameters. We have to read inputs. Then we're going to actually have to generate our pairing. Generate new pairing. So this is our list. Well, this is our name list. And old pairings. Generate new pairing, and then we write our pairing. Okay, so that's kind of like a very high level view of what our program is going to look like. And a lot of programs are basically going to have this general form. You're going to process your parameters, you're going to read your inputs, whatever those are. When you read those inputs, you're reading them and you're producing some kind of data structure, some kind of set of variables, some set of objects that it represents those inputs in some way that's convenient for you. But we won't go into too much detail yet about what that is. Then we take those inputs and we have to generate a new pairing. So that's basically, we can start to imagine how that might work. We have a name list. So we're going to have a new pairing that has, for each of those names, we have some other name that it's paired with. And we have to follow those rules that those requirements that we defined above. Don't pair with yourself and don't repeat previous pairing. Once we have our new pairing, then we write that as our output. Okay, so we can now think about, okay, how do we break these things down? Well, processing parameters in PowerShell is pretty simple. We just have, we define the parameters in the script. It already pretty much does all the validation for us. So reading the inputs is really where it's going to get a little bit more interesting. And of course, generating the new pairing. Now, if the name list is just a text file, reading the inputs is just reading a text file. If the old pairing is a CSV file, say, then PowerShell has a very simple way of doing that. We can read a CSV file. The question is, how do we represent the results of that in our program so that we can use that to generate a new pairing? And this is where we get into the core of the program, which is going to be some sort of algorithm for generating a new pairing. So, so let's think about that a bit more. Now is where we start having to go into a bit more detail. So let's say we have some names. Let's just go with, I'm going to go with, if any of you are old enough to have ever watched the Flintstones, I'm going to pick the Flintstones cartoon. I'm going to go with Fred. Wilma, and Pebbles. And we have Barney, and what was this? Betty, and Bam Bam. Bam Bam is maybe a useful example to have in our input because there's a space in there. So we want to make sure our program works with names that have spaces. Okay, and so what do we do with that? Well, we're going to basically do a matchup thing, right? We're going to have the same names again. But we need to match them up. Let's go with a different color here. So let's say Fred will give to Wilma. Wilma will give to, we'll just pick one at random, Betty. Pebbles will give to, I don't know, Fred. Barney will give to Pebbles. Betty will give to Bam Bam. And Bam Bam, who's left out? Who hasn't gotten one yet? Barney, I guess. Okay. So we have to generate these red lines somehow. So essentially, how do we represent this? Well, there's different ways we could do it. You think of pairs. We could have just an array of objects. Each of objects has, a from name and a to name. That's kind of how the output's going to look. So we could store this as an array of objects, each of which has these two strings. It makes it, that's that's not a bad way to go necessarily. Or we could say maybe we just have a list of names and we have an array of numbers. So here we have, 0, 1, 2, 3, 4, 5. Okay, so we could think of, we have, 6 names here, so we could have an array of 6 integers. Okay, we have 0, 1, 2, 3, 4. Oops, I could put in one too many. Oh, there we go. 5. So in this case, if Fred is giving to Wilma, Fred is at index 0, so his recipient is 1. If Wilma is giving to Betty, Betty is 4, so 1 is mapped to 4. If Pebbles is giving to Fred, then Pebbles is at index 2, and she's giving to Fred, which is represented by index 0. Let's see, 3 is Barney. Barney is giving to Pebbles. Pebbles is 2, so 3 maps to 2. Betty is giving to Bam Bam, so 4 maps to 5. And Bam Bam is giving to Barney, which is 3. Okay, so we end up just with an array, 1, 4, 0, 2, 5, 3. Now, how do we express our rules? So additional requirement, of course, would be you're not paired with yourself, you don't repeat previous pairings. Also, each person is paired only once, right? Okay, so what we see here then is we just have an array of numbers from 0 to 0 to 5, where each number we can represent our pairings just as an array of numbers from 0 to 5, given 6 names, where each number is this allows us to define this mapping in a very efficient way, and our rules are that each number only appears once. The number at index n, whatever n is, can never be n. The 0 cannot be paired with 0, so the number at index 0 here can't be a 0. And then as far as the history requirement, the don't repeat previous pairing, we would have to remember the numbers from the last time around and ensure that we don't use the same number we did before. Okay, so that's actually looks promising. And then when we go to write our output, we're going to be writing pairs of names. So at index 0, we would write, for index 0, we would write name 0, which is Fred, and we write that's as the from address, as the sender or the giver, and name 1, Wilma, as the recipient. So we can see how this can easily be mapped to Fred, Wilma. And 1 is paired with 4, so we have Wilma gives to Betty. Okay, so this is how we could use this array to produce our output. Okay, that seems like a promising approach, because we can imagine kind of taking an array. We could start with just the numbers 0 through 5 and then just sort of randomly shuffle them, and then see if it meets our rules, and then keep shuffling them until it does. That might be one way to go. We would want to make sure our program eventually finishes, so we don't want to have a situation where we can't meet our requirements. I guess as long as it's random and there is some order of numbers that meets the requirements, it will eventually terminate. It might not be the quickest thing, but it will eventually terminate. But if we only had 2 names, for example, well, if we only have 1 name, there's no valid mapping, right? Because 0 would have to map to 0, which doesn't meet the rules. So we'd have to rule that out. If we have 2 names, let's say we only have Fred and Wilma, then there's only 1 valid mapping. 0 would have to map to 1, and 1 would have to map to 0. So now if you go and repeat this next year, you're always going to run afoul of your history requirement. So maybe we should say that there always have to be at least 3 names. Okay, so we'll define that as another requirement. At least 3 names. Because if there are only 2, it's kind of trivial. Each person's they're just going to swap gifts no matter what. Okay. All right. So let's say that is our. So we haven't written anything down about our algorithm, but we have kind of this idea that we could do this. So we could let's define our algorithm. So we've got we've got our general outline of how the program is going to work is we process parameters, read inputs, generate a new pairing, and write a new pairing. So if our algorithm of how do we generate a new pairing is okay, actually, first of all, with read our inputs, now we have an idea that we're going to use this our data model kind of is our data model, right? This is how we represent the data internally so that our algorithm can operate on the data. So our data model is we have an array of names, we have an array of strings, so it's an array of strings. We have an array of let's see. So a pairing is an array of int, okay, where the index is the from and the value at that index is the to. Each of these indexes are indexes into the array of names. Okay, so that's a pairing. So when we read our data, so reading inputs, we have to read the array of names. Into a string array. We have to read the old names into an integer array. Read the old pairings, rather, into an integer array. Then we have to actually, so that's sufficient, I think, for our inputs. And then to generate a new pairing, there's lots of ways we can approach this, but I'm going to go with kind of a brute force approach, which is just to generate a random sequence of integers, or randomly shuffle the sequence of integers, right? Create a sequence from 0 to n, where n is 1 less than the number of names. Randomly shuffle that sequence. Validate according to rules. And then, if not valid, repeat. Okay, so we'll just start over again, randomly shuffle over again, create a new sequence if the If the result of this first time around doesn't meet our rules, then we'll create a new sequence. Now we could do something closer to pulling out names out of a hat. So for example, maybe what we do is we start at index. There's other possible algorithms, is basically what I'm saying. So one idea is we start at index 0, and we assign it a random number in the range, 0 to n minus 1, or 0 to n, where n is 1 less than the number of names. And we check whether that particular name is already used, is already valid. And maybe pick a different number if that's the case. Or we basically have to have some way of keeping track as we go on a per name basis. This is kind of closer to what we do when we're drawing names out of a hat, right? When we remove a name from a hat, when we draw a name out of a hat, we remove that from the hat so we don't draw it again next time. And each time we draw from the hat, if it matches a previous name, we'd have to put that name back in the hat and draw another name, right? So that'd be one way to go. We'd have to have this concept of removing names from the hat, if you will. And the other thing about it is you could get into a sort of dead-end situation where you have to start all over anyway. So, for example, let's say that we have, we have 3 names. Let's say we have Fred, Wilma, and Pebbles, right? So let's say last time, I'm gonna simplify this to 3 names for the sake of argument here. Okay, we need our black again. Okay, so last year, Fred gave to Wilma, Pebbles gave to Fred, and Wilma gave to Pebbles. Okay, so this time, let's say that we randomly draw a name. Well, actually, this only has 2 valid mappings. In order to run into this, we have to have a different. We have to have at least one more name, I think. So let's say we have Barney. And last time, well, Barney couldn't have given to Barney, so that's not a valid configuration, right? So Pebbles gave to Barney, and Barney gave to Fred. Okay, so now we generate our new mapping, and let's say that for Fred, we randomly choose Pebbles. And for Wilma, and that's allowed, right, so far. So now we've committed Fred as being Pebbles. For Wilma, let's say we randomly choose, I don't know, Fred. And now for Pebbles, we randomly choose Wilma. Okay, so far all those are allowed according to our rules. But then when we get to Barney, the only choice left is for Barney to give to himself, which is not allowed, right? So we could end up in a situation where we're stuck and we have to kind of start over again. So that's why I'm thinking that the simple brute force idea of just randomly shuffling the names, and if it is not a valid mapping, we just throw the whole thing out and start all over. It might be a better approach. There's probably a more efficient approach, but really efficiency doesn't matter a whole lot for this program, so I think that's where I'm going to go. All right, so we generate our pairings, and then we write our output. And essentially we're going to be converting our, we're going to use our pairings, which is convert our pairings, which is an integer array, into a CSV file. So we'll have to figure out how that works. But you know what? Each of these things we can go into a bit more detail as we get into it. I think that's certainly a solvable problem, so we'll have to figure out how that works, and we'll tackle these one at a time. So I think we've got enough detail now in our kind of whiteboard our whiteboard design to start writing some code. So let's do that. I'm going to open up a terminal window. I just right-clicked on the Start menu to get that menu, and then chose Terminal. And I have a Learn PS directory where I have a bunch of PowerShell scripts from previous videos I've created. So I'm just going to open that, and I'll start Visual Studio Code in this directory. So I'll say code, period meaning current directory. So it's opening the directory. And so here we are. We're in Visual Studio Code. So we're going to create a new script. I'm going to create a directory for that script. I'm going to call it, I'm going to just use the make dir command. And I'm going to call it, what did we call this thing in the whiteboard thing? We called it, oops, gift exchange. Okay, there we go. We'll call it gift exchange. Okay. And maybe before even starting writing our script, let's write some. Let's write an input file. Okay, so we're in our. Well, let's see. I'm gonna hit Control N to create a new file, and let's go ahead and say that this is our name list, and I'm going to go ahead and make it I'm going to put it in the gift exchange directory, and let's go ahead and make it a CSV file. I'm going to call this names.csv because I'm going to anticipate that maybe in a future version I want to actually include email addresses. Okay, so I'm giving it the .csv extension. Okay. And so a CSV file, generally we have the first line of the file is going to be our column headers. So I'm going to say name, comma, email. Okay, and then the lines after that, each row is each line after that, or each line is like the row of a table or the row of a spreadsheet. So let's go ahead and with the same with Fred, Wilma. Pebbles, Barney, Wilma, Bam Bam. And each of these I'm going to follow with a comma and an email address, and we'll say just Fred@Flintstone. And we'll do the same thing for each of the other ones. Call Wilma at Flintstone, Pebbles at Flintstone, Barney at Rubble, because these are their names. Oops, it was Betty, not Wilma. And okay, and we're not even going to use these emails for this program, but this kind of allows this file to be used for other purposes as well. Okay, so let's go ahead and create our PowerShell script. So again, I hit Control N to create a new file, and I'm going to save it by hitting Control S, and I'm going to call it get. So PowerShell have this kind of convention that the first name you have a verb hyphen object. So here we're getting a list of so draw isn't really an approved verb. There are certain verbs that are kind of conventional verbs. So get recipients, get gift. Oh, I'll just call it gift pairs. I'm not going to worry too much about the naming is important, but for this purposes of this video, I'm not going to worry too much about this. .ps1. Okay. And then we need to have our parameters. So the parameters, so in a PowerShell script, you can simply declare your parameters, and then PowerShell, when you invoke the script, will automatically expect you to pass those in. So we have two parameters. We have the file name of the names file, and we have the file name of the, which is required, and then we have the file name of the previous, the previous pairings file, which is going to be another CSV file, and that's an optional. So I always forget. I don't write PowerShell scripts every day, and I can always forget the syntax for declaring parameters. So I'm just going to look at some old script I wrote. Let's see, this one. Okay, this one has a parameter. So here's how we declare parameters. I'm just going to copy and paste that into my new one. Okay. So here we have this attribute says that the parameter is mandatory, and this isn't a date time. We don't want a date time, we want a string, and it's going to be names. Okay, and then we have another parameter which is not mandatory, this one, so I'm going to say, and it's also a string, and I'm just going to call it last. But we could be more explicit. We could say last pairings. We'll call it last pairs. And this one I'm going to give a default value because it's optional. Because it's optional. And that default value is null. Okay, so let's go ahead and just run this first of all to see if we can even run this script. So here we are. We're in our gift exchange directory, and we'll call get gift pairs. And if I just run this with no arguments, it prompts me for the names thing. So I'm going to say names.csv, and then we're done. Okay, it doesn't do anything else. And of course, I can invoke it explicitly by saying names.csv. Okay, so it hasn't actually done anything really, but we can always say write output names. And now if we run the script, when we run it, I misspelled write output. Okay, so now we've at least processed the parameters. We've received the parameters. We have that file name. So now we're at the next step of, let's refer back to our whiteboard thing. What's the overall process of our program? We have to process our parameters. We have to read our inputs. And then we generate our new pairing. So reading our inputs, we're going to read our array of names into an array of strings. And then we are going to read our old pairings, if there are any, into an array of integers. So for now, let's just ignore the old pairings. And let's read our names into an array of strings. Okay, so we can say get content. We'll call it name list. Okay. And I'm just going to say, actually, I'm going to say write host. Reading names. All right, just to be real. Give us a lot of, we can delete some of this if we don't think it's useful. We read names into the name list, and then it's just write output. Okay, and we'll see what we get here. All right, so we've read our names, and it's given us, basically when we call get content, or when we call get content on a file name, on a text file, it's just going to give us an array of strings. Likewise, if we say get content names.csv, right? I didn't mean to do that. Get content names.csv. Let's just do this interactively to help us look at this. So we can say names get type. Okay, it's an array of objects. We can say names length will tell us how many elements there are in that array. So there's 7 elements. So how many is that? We have name and email, Fred, Wilma, Pebble. So there are only 6 names, but there's also the heading, right? Names 0 is the name is the column headers. So we really don't, for our purposes, we really don't care about the column headers, and we really only care about the first column. We want the just the names, not any of the other columns. So how are we going to deal with that? Well, we want to convert this from CSV format. And there is actually in PowerShell, there's a commandlet to do just that. We can say names equals get content names.csv, and we can say convert from CSV. Okay, now we look at names. All right, now names is something different. Names.getType, still an array of object, but names0.getType is now a PS custom object that has these 2 properties. Let's see. And so it has and the properties correspond to the columns of so when converting from CSV, we end up with these objects that have the column names are the properties of that object. So we can refer to its name, and we can refer to its email, which we of course don't care about. Okay, so convert from CSV gives us an array of objects. So it's converted from CSV format into an array of objects by parsing that CSV file. And then we only really care about the names. So we can say select, was it select property? Select name. Oh, that's not what I want. Oh, I see. Yeah. Let's actually just take out this part right here. Okay, so that's one way of doing it. Or we can just say, I think this will work. If we just put this whole thing in parentheses, name, right? Then we just get the names. Okay, so that's how we're gonna. That looks pretty good. Let's go ahead and do that. I'm just gonna copy and paste that. Go back into my PowerShell, and this time I'm gonna say name list equals that. Except instead of hard coding names.csv, we're gonna hard code names, and then let's write up. So name list now is our array of strings. I think its actual type is just array of objects still, but it contains the strings. And so now if I run our script again, and I say names.csv, then we say reading names.csv, and then here's the value of that variable. Okay, so we got our names. We got our first step. So we need 2 things. We have our name list, and then we need our previous mapping or last pairs, right? So let's get our last pairs. So let's go ahead and oops. What did I just do? I need to undo that. There we go. I'm going to add a comment here. So let's assume for now that we don't have any previous names, but we still need to have a mapping for it. And that mapping is going to be an array of integers that with one value, with one element for each name. So if our name list has 6 names in it, we need an array of 6 integers. And each of those integers is going to be the index of whoever that person last gave to. And of course, we need a way of representing the case where that person didn't give to anyone. So we'll just use -1 in that case. So how can we do this? Well, we can start by just generating a default mapping where nobody gave to anyone. And we have to create an array of integers then that that has the same number of elements as our name list. Well, that number of elements is namelist.length. So we need a way of creating an array of integers that has that number of elements in it. So the syntax for that in PowerShell is we can new an array by saying, well, here, let's do it at the command prompt first. We can say, we can give a type. So we can say int, for example, new 1, for example, and that will give us, oh, did I get that wrong? Well, let's say we have int array new 10. Okay, that's what I wanted. So we've created an array of integers with 10 elements, and then since I didn't assign it to a variable, it just output that. And it default initialized each of the elements in that array to 0. So that's how we can create our array of integers. So let's go ahead and do that. I'm going to copy and paste that, go back in here, and say, I'm going to call it old pairs. Equals int new, and the size of that array is going to be equal to the number of names. Okay, so I'm going to create a all right, and then I'm going to, right now, initially that old pairs is going to be all 0, so it's going to look as if everybody gave to whatever the first name is. I'm going to change that by assigning all of them to setting all of those to -1. So I can say for $i equals 0, $i less than old pairs dot length, $i plus plus, old pairs $i equals -1. Okay, so let's go ahead and write that. Let's go ahead and say okay, so we've read Fred, Wilma, Pebbles, Barney, Betty, Bam Bam, which is what, 1, 2, 3, 4, 5, 6 names, and we then created an array of 6 integers, all of which we've initialized to -1. So that's our old pairs. Now, what if we actually have our old pairs? So remember, last pairs is an optional parameter. Okay, but I'm just going to leave that as a to-do for now, because we can come back to that when we actually have some data to read. For now, I think we can just use the handle the case where no last pairs are specified. Okay, now let's go back to our thing. We've read our inputs. We've read the array of names into a string array. We've read the old pairings into an integer array, which is now we need to generate a new pairings. So we want to create a sequence from 0 to n. We then shuffle it randomly, and then we validate according to our rules. So maybe the first thing we hunt here is to write a function to validate. So test is a PowerShell verb. And so we'll take one parameter, which is the pairing, and we'll actually specify that it's an array of integers. Let's actually not write this yet. Let's just put that as a to-do also. And we'll just assume it's valid for now. Let's then write another function that we're going to use to shuffle our pairing. And again, we'll put that as a to-do for now. Right now, it won't do anything. And then let's write our function to put it all together. Well, yeah, we'll call it generate pairing. We'll call it create pairing. I'll call it get new pairing. Well, I'll just call it new pairing. I think new is a valid PowerShell verb. Okay. So, new pairing. Basically, we want to do this repeatedly. So we're going to generate a sequence from 0 to n. N being, the size of that, the length of that sequence is going to be the number of names. Then we are going to shuffle it, and then we'll test if that shuffled sequence is valid according to our rules. And if it is valid, we'll break out of our loop. Otherwise, we'll continue on. So let's try this. Let's start with just creating our array. Pairing equals int new nameless.length, same as we did above. I'm just going to use the name pairs instead of pairing. Pairs. And then I think a do while loop is appropriate here, because we're going to do this at least once, and we're going to keep doing it until we have a valid pairing. So while not test valid pairing pairs. And then when we're done, the output of the function is just pairs. I'll say write output pairs. Okay. So at the beginning of each loop, we're going to initialize basically we're going to do the same thing we did here, except that here we initialized all of them to -1. Now we're going to initialize all of them to whatever the current index is. Initialize to a sequence, and then shuffle oh look, this is the danger of copy paste. Pairs, not old pairs. Okay, so we create the array, we allocate the array once. Then for each iteration of our loop, we initialize the array to a sequence from 0 to n, 0 up to, but not including the length of the number of names. Then we shuffle our pairs, shuffle that sequence, basically reorder it into a random order. And Then we test if it's a valid pairing. If it is not a valid pairing, we're going to repeat our loop body. If it is a valid pairing, then we're going to fall out of the loop, and then the output of the function is that resulting pairing. Now for now, shuffle pairing does nothing, and test valid pairing always returns true. So for now, the pairing we're going to end up with is just going to be a random sequence. Actually, it wouldn't even be a random sequence. It'll be from zero. It'll be from zero to the. It'll be the sequence from whatever to whatever. So it's not going to be valid. But that's okay because we're going to fill in those details as we go along. The next thing is let's go ahead and have a write output. Write pairing. And this is where we're going to produce a CSV file. And that contains our results. So let's go ahead and have our variable or our parameter. So I think convert to CSV, I think it's going to want an array of objects where each object has a from and a to property. I think because when we convert from CSV, so there is a convert to CSV function. So if we just say pairs convert to CSV, I don't think that's going to do anything sensible because it's just an array of integers. I think we want to convert this to an array of objects, each of which has a from and a to property. So let's define a class, and I don't know why I did that. Class pairing, and we'll give it a string from and string to. Okay. So we're going to have, we'll just call this A, our result. Well, go from pairs to pairings, which is pairings equals we're just going to create an array of objects. Maybe I can say pairing. Could I create an array of pairing? I'm not sure if this is going to work. New pairs.length. Oh, of course I need to assign it. So we'll see if that works. Okay, so this is creating an array of objects of type pairing. So this inside the brackets is the type we're creating. The type itself is an array of pairing. We're going to create this new array. The length of the array is going to be equal to the pairs.length, which is equal to names.length. And then we're going to initialize each of the objects. So we'll say for I equals 0, $sign I is less than pairs.length, $i plus plus. And pairings I'll say obj equals new pairing, new object, type name, pairing. object from is equal to names. Now, remember that with our pairing, the index into the array is the sender, the giver, and the value at that index is the recipient. So from is simply name list is our variable that we have here. So from is name list, and 2 is equal to name list pairs. Okay, so here we're using the index I. The I is just going from 0 to the number of names minus 1. We just take that index I itself, get the name at that index, and that's the sender, the from name. The to name is we get by getting the paired index, right? So we look into our pairs array to get the index of the to of the recipient, and then we take that as an index into the name list to get the string value of that. Okay, and then we'll store that object in our pairings array. You know what? Instead of doing it this way, I'm going to have a function called get pairings. Get pairings. And I won't bother creating this array. And I'll just say write output option. Okay. All right, so now we have these functions defined. We have a function to generate our new pairing. We have a class that represents a particular pair of sender and recipient. And then now we can write, we've read our input. And so now we can actually generate our pairings and write our output. So we say pairs equals get pairings. Get pairings, does that take a parameter again? Oh no, it's new pairing, sorry. New pairing. I think these names leave something to be desired as I'm working on this. It's a little confusing that we have get pairings and new pairings, and these represent kind of different things. Here we have an array of pairing objects, and here we have an array of integers. So I think maybe I would prefer to call this something else. We could call this we could call this a pair map, say. The array of integers could be a pair map or name map. We'll call this old name map. Okay. And then we'll call this a name map. And we'll call this new name map. Let's call it get name map. The map is a pretty good word here because essentially we have an array of integers that's mapping one set of values to another set of values. So the index into the array is the from, and the value at that index is the to, but both of these are indexes into the name list. Okay, so we have name map, and okay. We could call this shuffle name map. Kind of think of it, we don't really have to do this step except once. Initialize. So we create a sequential name map. And then we shuffle the name map. Okay. What's it warning about here? Oh, it's unapproved verb. Well, I'm not going to worry about that. Okay, so we have name map equals get name map, which, as I recall, doesn't take any parameters. Then we have then we can say get pairings. And we can then convert that to CSV. Okay, so let's try running this now. Good, so we've gone away. We've done bit here without actually testing anything. Let's see how that works. Oh, it doesn't like convert to CSV. Is it? Did it? Is it convert to? Maybe convert to is the verb. I can't remember. Convert to CSV. Ah, that's more like it. Okay, so let's run that. Okay. Reading names, and it gives us from to. Yeah, all right. So we have our column headers are from and to. This is kind of what I would expect. The first row of the CSV file would be the column headers from and to. We have Fred giving to Fred, Wilma giving to Wilma, or Wilma. They all give to Fred. That's interesting. I would have expected. Since we did our sequential thing. Oh, we've assigned them all to -1. That's name map equal $i equals $i. Let's try this again. So now Fred gives to Fred, Wilma gives to Fred. Oh, they all give to Fred. That's also a bit odd. Let's go ahead and write our name map up it just to see what we have here. Ah, so they're all 0. So that's not what I expected. We created a name map. We went from I equal to 0. I is, oh, instead of pairs, because pairs.length isn't even defined, so we have to change that to name map. So this loop is not really executing because pairs.length, there was no pairs, and so it's just treating that as 0, I guess. All right, so let's try running this again. Okay, now we have the sequence 0, 1, 2, 3, 4, 5. We have our column headers correspond to the names of the properties in our pairing object. And we have Fred giving to Fred. That's the first array index. 0 is mapped to 0. We have Wilma giving to Wilma because the value at index 1 is 1, and likewise for the others. Okay, so that's working pretty well. Now we just need to fill in our gaps. Shuffle name map. Okay, so let's try that. Let's just randomly shuffle them, but not worry about whether it's valid. Well, there's a random class. I'm going to create that once up front before we do anything else. So I'll just call it R. And say random new. Okay, so we have this random class. This is part of the .NET framework. You can just search for random, but it has one of the methods it has is called next, which takes we can take a parameter, which is the number of So let's go ahead and create a random object on the command prompt here. So we'll say $R equals random new. And if we say r.next 2, for example, it's going to give us a number, an integer, a non-negative integer that's less than 2. So in this case, it's going to be 0 or 1. So we call this over and over again. Sometimes we'll get 0, sometimes we'll get 1. We'll never get a number. So there's only 2 possible values it can return, right? That's another way of thinking of it. If we say this is 10, it's going to give us a number less than 10. So it could be 2, it could be 6, it could be 7, it could be 1. And it's it's pseudo random. It's not literally flipping a coin, but it's random enough for our purposes. Okay, so to shuffle our name map, I'm just going to iterate over our array again, and I will randomly swap each item with an item that comes somewhere after it, I guess, or somewhere before it. Let's see, I could start at index 1. How do I do this? And choose and randomly swap it with an item either at 1 or at or before 1. Okay, so let's try that. So I'll say for I equals 1, I less than name map dot length. Okay, so we're iterating over all but the first index. And so for each item, swap with itself or a previous item randomly. Either swapping with itself, of course, meaning not swapping it at all. So let's say j equals r.next is I plus 1. Okay, so we're going to get an index that is either equal to or less than I. And then if j is less than I, then we'll do the swap. So temp is equal to name map j. Name map j is equal to name map I. Name map I is equal to temp. So this is how we're doing the swap. We assign the value at j to a temporary, then we set the value at j to the value at I, and then we set the value at I to the old value at j. And that should give us a basically a random shuffle of the sequence that we started with. So shuffle name map. So we call that from here, and so we should this time we should have a random sequence of let's go ahead and run our program again. So now we have Fred giving to Wilma, Wilma giving to Betty, Pebbles to Fred, Barney to Bam Bam, Betty to Barney, and Bam Bam to Pebbles. So now it's a random assortment. And we can see that it meets some of our requirements because each name only appears once in the left column and only once in the right column. But there's no guarantee, because we haven't implemented our validity check, there's no guarantee that Fred won't give to himself or that somebody won't give to a person they gave to last year. So next we have to implement our test valid pairing function. And that should be fairly simple. Basically, for each I going from zero up to the number of names minus 1. So for I equals 0, I is less than name map dot length I plus plus. And there are 2 reasons it can be invalid. It can be valid because the recipient is we'll just call it J, let J be the recipient. J equals name map. Okay, and there's two ways the J can be invalid. If J is equal to I, so you can't give it to yourself. Or the other possibility is, remember we have our old name map, or J is equal to old name map I. Then return false. But if we get all the way through our loop, if we follow through, then it's valid. If we get all the way through the loop and none of them are invalid, then it's valid. So that's where we return true. Okay, let's try our program again. Reading names.csv. Uh-oh, we have a problem here. Looks like we might have an infinite loop. Perhaps we're always returning false for some reason. Oh, well, let's just comment that out. Oh, that's interesting. So we're not returning, it's not because, because I forgot to do the I++. I didn't increment I, so we never finished that loop. We just looped forever because I never changed. All right. Okay, so now we should have a thing that meets all of our requirements. And with the exception of one, that we haven't saved our new name. We haven't actually read the old name map. So let's go ahead and do that. Let's see now. First of all, let's take out some of the output that we don't need. So we don't need to write that. Let's run our program again. Okay, so this time let's go ahead and pipe and call set content, and we'll just call this last year.csv. Okay, so now if we look at our, if we go to our, here we have our last year CSV file, and here we have our name. So this is our inputs. So now when we run our program, let's specify that. We'll say last pairs is last year.csv. Okay. Now we're not actually reading that yet. So the only thing left, I think, in our program is to read in the last pairs. Before I do that, though, let me just put in one other little thing here, just to make sure that our validation test is actually doing something. Let's say that if we do reject a mapping, a pairing, just say write host. I'll just say skipping invalid pairing. By the way, this is the difference between write output and write host, is that output is essentially the return value from this function, whereas host is always just kind of written to the console, written to the terminal. So let's run our program again. And we didn't see any invalid pairings, but there we did. Okay, so when we did our random shuffling, we had a couple of invalid pairings before we find a valid one. So sometimes we'll find them, sometimes we won't. That kind of gives us at least some confidence that our logic is working. Okay, let's go ahead and read our last pairs now. Okay, so last pairs is not null. Let's go ahead and read those. So it's a CSV file, if you recall. So we can say get content last pairs convert from CSV for each object. Okay, so essentially, each of these objects. Remember when we convert from CSV, we end up with a array of objects, each of which has properties that correspond to the column header. So last year, remember that the column headers now are from and to. So we should have a from property, which is the giver, and a to property, which is the recipient. So basically, we want to convert each of those to indices by looking them up in the old in the name list. So I'm just going to call them I and J. Let I be the giver index. And there's an index of method here, which $_ is the loop variable that when we use a for each object like this, there's this automatic variable that's defined called $_, and from is going to be the from property here. So let J be the recipient index. And it's going to be the same thing, except that it's the to property. Now, when we do the index of, we're looking for an element of the array that matches the given value. It's going to return the index of the matching element. If no element matches, index of is going to return -1. So if both the giver and the recipient are known names, they're in our name list, then we should update the old name map accordingly. Otherwise, we don't do anything. We ignore it. So if $i is greater than or equal to 0, and $j is greater than or equal to 0. So both of them are in our name list. Then last pairs, remember the index into the, sorry, it's not last pairs, it's old name map. Old name map. Last pairs is the file name. Old name map. The index into the old name map is the giver, so $i, and the value is the recipient, $j. Okay, so now we've read our so we create the name map for the previous mapping, initialize it to all members -1, so that in other words, none of them are there. We'll initialize the random object down here. We'll put it down here somewhere because that's where we use it. Okay, so that should work. Let's try it. So we had more instances where we skipped an invalid pairing. Just for a little bit more information. This is really just for debugging purposes to see if this is working the way we expect. I'm going to put skip invalid pairing. And I'm going to put name map $i. Not name map, name. list. Basically, as the output, I want to show what name it was, what pairing of names. That it rejected. Okay, so here it rejected bam bam to bam bam. Then it rejected pebbles to pebbles, pebbles to pebbles again, Wilma to Fred. So here's an interesting one. So it rejected Wilma to Fred. Why would it reject that? Well, it should be because last year Wilma gave to Fred. Okay, so this is showing us that that's working. It rejected bam bam to Betty. So last year bam bam gave to Betty, line 7 here. And at the end, when it's done with all of them, we have a mapping that shouldn't include any pairings that are either to themselves or to something that was in last year's pairing. And again, we can always omit the hold on. You can always omit the last pairs. That's still an optional parameter. Oh, that's interesting. Line 20, it didn't like. So we called get content even though it was so that's interesting. Last pairs. Should have been null, I would think. I'm just going to take this out and do it this way. If last pairs. Okay, that's more like it. Instead of comparing with null, I'm just saying if it, I guess it's treating the null as a false. And it's, again, ignoring last pairs, it's just rejecting the pairings with the names giving to themselves. Now let's go back to this. We didn't get any mismatches. Now it's rejected Wilma giving to Fred, and it's rejected Barney giving to Barney. So this one is because of the last pairs, and this one is because of the names giving to itself. Okay, so that seems to be working. We've tested both cases. And I guess we could another thing to test would be, what if we add a name? So let's say we add the Simpsons in here, right? We have Homer. Okay, so we've added a name, and interesting, we've got a bunch more invalid pairings, but we do end up with Homer now is giving to Pebbles. We do have all the expected number of pairings. Barney's giving to Homer. So, okay, seems to work. So that is our script. So let's go back and review a little bit, kind of how we approach this. Oh. Okay, so starting out, we had our, thinking like a programmer here. We had an idea. We tried to choose an idea that seemed simple enough to be doable in a reasonable amount of time, or with, at your skill level that you're at. We iteratively refine the idea by starting out with just the vaguest idea. Well, we're going to have a list of names, and we're going to randomly reassign them, and we're going to write some sort of output. Then we iteratively refine that by saying, okay, well, what form is that list of names going to take? And we eventually decided on a CSV file. Then what other constraints do we have? Well, we have this constraint that that we don't want to give to the same person 2 years in a row. So that means we have to keep track of last year's pairings. And so we have that as an additional input. So we have the last year's pairings as an input, and we have the current list of names as an input. So now we've defined 2 inputs. And then we have, we've refined our requirements to say that the output should be a pairing of names in CSV format, and also that we have certain rules. We don't pair with ourselves. We don't repeat previous pairings. And of course, each name is only paired once. And I didn't actually write that as that each name has, that we have at least 3 input names. We could actually have, right now the way it's written, I didn't check that, so we could have a situation where if you only passed in 2 input names, for example, 2 or 3 input names, you might never get a solution. So I'm not going to worry about that right now. But so having then kind of defined what our behavior of our program should be and how it's going to be executed, then it was time to actually implement the program. And this too we did by kind of taking a bit of a divide and conquer approach. We have our overall program design, but we can break it down into smaller steps. So, and that's essentially, that's what functions are for, right? So we start by processing parameters. In PowerShell, that's kind of trivial, so didn't go into much detail there. Then we have to read our inputs, which is the name list and the old pairings. Then we have to, the core algorithm of the function is to generate the new pairing. That's where we actually have to apply all of our rules. And then we have to write the new pairing, which is writing a CSV file. So we kind of broke that down further. We thought about, well, what is our algorithm going to be? And to do that, we had to think about how are we going to represent pairings. And to do that, we settled on a design where we have essentially 2 things. We have simply a list of names, which is an array of strings, and then an array of integers, which defines our mapping of names. So the index into our array is the sender or the giver, and the value at that index is the recipient. Both of those indices are indices into the array of names. So having done that, we can define our, we can read our inputs by reading both the array of strings from our CSV file, and then we have to read the old pairings into a mapping, which is our array of integers. Then we can generate our new pairing, and we decided on an algorithm where we simply start with a sequence from 0 to n, 0 to the number of names minus 1, and then we shuffle it, and we keep shuffling it until we have one that meets all of our rules. And then finally we write the output, and we did that, and in all these cases we did this by writing some functions to break each piece down into smaller pieces. So okay, so going back to our script, we have our parameter. We take advantage of the facilities PowerShell provides to convert from a CSV file and then get just the name, because our CSV file has multiple columns, but we're just interested in the name column. So we store that, and what this ends up being just an array of names, the name list. This is where we continue reading our inputs. We read we create a old name map, which is an array of integers with equal to the size of the name list. And we initialize that to all of them being -1. So this is for the case where nobody is given to anyone before. Then if a last pairs parameter is specified, that's when we update that old name map by storing by getting the from and the to, the giver and the recipient. We get those from the CSV file, and we find them in our name list. And if so, we update the name map to reflect those values. Then we determine that, well, part of our algorithm to generate this is to test if there's a valid pairing. Step 3 here, validate according to rules. Well, this is where we validate according to rules. We have a name map, which is just an array of integers. We defined a very simple way of determining if it's valid. And just for debugging purposes, we included this right host statement. That's really just for debugging purposes. I'll just comment that out. Then we have part of what we need to do also is be able to randomly shuffle our array. So keeping the same values, but shuffle them. So this is just a simple algorithm for randomly shuffling something. So we have our random object. We create the random object once, and then we use outside the function, and then reuse it over and over again. This is just because of the way that the random class works. When you construct it, it creates it with a seed value that's generated from the system clock, and then it generates a sequence of numbers based on that seed value. So it's really kind of deterministic given a certain seed value, but and that's why we don't want to just create the random object new every time we call the function. We want to create it once, and then otherwise we might end up with the same. If we call it too fast in a sequence, we'll get the same value because the clock won't have ticked. But if we use the same object and just call next, next, next on it, we'll get a random sequence. Okay, so we had a shuffle function, and then here's where we get our name map. So this is where we implement our whole algorithm that we've defined here of generating a pairing. So we create an array of integers the same length as the name list. We essentially initialize it so that each person is giving to his or herself by setting the value at index I to I. And then we shuffle it, and we keep shuffling it until we end up with a valid pairing. Once we have a valid pairing, then this expression will be false. In other words, the not valid will be false, and so it will follow the loop. So at this point, we have a valid pairing, and that's what we return. The pairing, again, being an array of integers. And then finally, in order to produce a CSV file, we want to have an array of pairing objects, each of which has a from and a to. So we wrote a function to get these pairings. So for each integer in the name map, which I called pairs, but we could have called name map here, we create a pairing object. We set the from, the sender, that is, the from value, the from property, to the name associated with the current index, because remember the index into the name map is the sender, and then the value at that index is the index of the name of the recipient. So pairs $i is the index of the recipient's name. $i is the index of the sender's name. So we set the from and to properties of this object and then write that to the output. So the result of calling get pairings is going to be an array of pairing objects. Piping that to convert to CSV gives us our CSV output. And then, of course, when we invoke that from our command prompt, we can also then call a set content next year. Or we'll call it this year CSV, and then we have our result. So we have last year, this year. Okay, so hopefully that gives you some sort of an example of the process of writing a program. And of course, one thing to bear in mind is some of this stuff is maybe a little tricky. There are lots of different ways you could have approached the algorithm of the core part of this program was generating the new mapping. And there's kind of this idea of, well, using a array of integers for our name map. Maybe you would have instead be tempted to use like a hash table of strings, and you can probably make that work. So there's lots of different ways you could approach this problem. I just went this particular way. And how you go is going to depend maybe on, you might go down a different path that maybe will turn out doesn't really lead to a solution as quickly. I took the path I did partly just because based on experience, I had some idea that having an array of integers would be a simple way of solving this. A lot of that comes with, the sort of toolbox of ideas you might have in your head comes from just having written a lot of programs before and solved these things. Don't get discouraged if you don't come to a good solution right away. You may have to go have more wrong turns than I took here. I did do some things where I tried something and I went back and changed it and did something different. But maybe you have more wrong turns because you haven't done something like this before. So don't get discouraged if you have to, if the obvious solution doesn't come to you right away, if there isn't an obvious solution. There's a lot of trial and error sometimes involved in being able to find something that works. And so have patience with yourself and don't get discouraged because there's really no algorithm to being able to write a program. That's why it's a creative process. It's a process that's kind of an art as well as a science. So, but hopefully just walking through something like this will be give you some ideas. Um, if you want next steps to try yourself, you could try to think of some similarly simple program, something that's not, that seems not too different from this one. Or you could try implementing the same program but in a different language like C# or something. And good luck with writing your own projects. I hope that helps. Thanks. Bye.